starting off with data representation, which has to do with base conversion from decimal to hexadecimal, binary, and all of that. So yeah. So first we're going to start the conversion from binary to any base. That's conversion from decimal to any base, and decimal is in base 10. So our normal numbers 1 to 10, all of them are in base 10. So to convert to any other base, for example binary, you can just do that by dividing the number you want to convert by the base you are converting to. So if you want to convert, let's say 3 to base 2, you can just divide it by 2 to have 1 remainder 1. If you divide it again by the same base you are trying to convert it to, this 2, you have 0 remainder 1. And to get the full conversion, we're going to take it from bottom up. So 3 in base 10 is equal to 3 in base 10 is equal to 11 in base 2. Does everyone understand? And if you want to convert from another base to base 10, there's a formula which you can use. A So let's try to convert 3 back to base 3 in binary back to 3 in base 10. Yeah. In n is the for base, yeah, n is the power. So for base 2, we're going to have the first number here is 1. So it's going to be 1 times the base we are trying to convert, the base from which we are trying to convert to 10. We're trying to convert from 2 to 10. So it's going to be 1 times 2 raised to power 2 minus 1 plus, this is 1 plus 1 times 2 raised to power 2 minus 2 equal to 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. And this is going to give us 2. Anything raised to the power of 0 is 1. So it's going to be 2 plus 1. This is going to give us 3 in base 10. Does everyone understand this? Where did I get from the formula? Two. That's the base we're trying to convert from to base 10. Yep. Or should I try another example? Yeah. That's where we got the 1 from. This. Yeah. Oh. Sorry. There's actually a mistake here actually. I was just supposed to start from this is what I was supposed to use. This last two. So it's going to be 1 times 2 raised to power 1 plus 1 times 2 raised to power 0 plus 2 plus 1. Does everyone understand that? Okay. So I can rub it off. Alright, okay. Now I want to try out conversion from base 10 from decimal to hexadecimal. That's from base 10 to base 16. 16. As we all know, now let's get 2 raised to power n for our decimal numbers. For 0 to 15, so 2 raised to power 0 is 0, 2 raised to power 1 is 1, trace power 1 is 2, trace power 2 is 4, 8, 16, plus 2, 64. Now to get the hexadecimal conversion of these numbers, what we're going to do is we're going to take each number and we're going to divide it by 16. So for this, now we're converting to hexadecimal. From decimal to hexadecimal, we're going to divide the number by 16. Dividing by number by the base you are trying to convert it to, which is 16. So for 2 raised to power 0, which is equal to 0, have 0 divided by 16, which is 0, remainder 0, which means the hexadecimal conversion of 2 raised to power 0 is going to give us 0. So for 2 raised to the power of 1, 2. The hexadecimal conversion is going to be 0, remainder 2, gives us 2. So hexadecimal conversion of 2 is 2. Up to 8, we're going to have the same conversion. And from 2 raised to power 4, which is 16, the conversion is going to be 1 remainder 0 and 0 remainder 1, which gives us 10. Which gives us 10. We are converting 2 raised to power 5, which is 32, to hexadecimal. That's going to be 16 in 32 is going to give us 2, remainder 0, and 16 in 2 is going to give us what? Okay. It's going to give us 0, remainder 2. So our hexadecimal conversion of 2 raised to power 5 is going to be 20. Or 2 raised to power 6, which is 64. 64 divided by 16 is going to give us 4. Remainder 0. 4 divided by 16 is going to give us 0. Remainder 4. So our hexadecimal conversion of 2 raised to power 6 is going to be 40. For 2 raised to power 7, which is 128, our hexadecimal conversion is going to be 128 divided by 16, right? Does anyone have a calculator? 8, right? 8 remainder 0. 8 divided by 16 is going to give us 0, remainder 8. So our hexadecimal conversion for 2 raised to the power 7 is going to give us 80. And for 2 raised to the power of 8, which is 256, so 256 divided by 16 is going to give us 16. Remainder 0. 16 divided by 16 is going to give us 1. Remainder 0. And 1 divided by 16 is going to give us 0. Remainder 1. So hexadecimal conversion of 2 raised to the power of 8 is going to be 100. For 2 raised to the power of 9, which is 512. 16 divided by 512 is going to give us 32. 32, remainder 0. 32 divided by 16 is going to give us 2, remainder 0. 2 divided by 16 is going to give us 0, remainder 2. So our hexadecimal conversion for 2 raised to the power of 9 is going to be 200. So I would like us to complete the remaining on our own. And if anyone has any, you can complete the remaining on our own in the next 2 minutes. If anyone has any questions, or if anyone is finding it hard to convert it, you can just call my attention. It remains 2 now. 16384. Where's your pen? 16384. 3, 2. Wait. Let me check it now. Let me check it. Are you done? Yeah. So, well, have you tried converting to Aspire? Okay. I've tried converting to the hexadecimal. didn't do the last one.
This one. Okay, sorry.
So you guys are this.
That one is no problem.
That's something.
Not. Is there any complex? Because the way you're doing.
Yeah, but I'm not sure I'll be able to get into it today.
Okay. So this one you'll be able to teach today.
No, I'm not finished. There's still conversion from binary to hexadecimal. And hexadecimal, hexadecimal is one that has symbols. That has letters, F and stuff. Converting to binary and binary to hexadecimal. You're not going to multiply. Oh, you see where already. So I guess we're all done with this. Let's try converting from binary to hexadecimal. So can I have your attention, please? So when now we're about to try converting from binary to hexadecimal. So let's take this as an example. 0, 0, 1, 1, 1, 1, 1, 1, 0. This already is in base 2. And I'm going to try to convert this into base 16. What we can do is we can try grouping the binary conversion. We can try grouping this into groups of 4 bits each. That means we'll divide this into 3 different groups of 4 bits each. So we can try converting each of them to the base of 16. So this is going to give us 3 in decimal. So now we're going to try converting 3 in decimal to hexadecimal. So we're going to take 3, we're going to divide it by 16. So we're going to get 0 remainder 3, which means 3 in decimal is also 3 in hexadecimal. I'm going to take this this is 15 in decimal, and 15 in decimal. What? Okay. What? How did I get 15? To get 15, I'm going to do this 1 times 2 raised to the power of, this is 0, this is 1, this is 2, this is 2. So 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0 is going to give us 8 plus 4 plus 2 plus 1, which is equal to 15 in base 10. So this is going to give us 15 decimal, which is also F in hexadecimal. So converting this also into decimal give us 1 times 2 raised to the power of 3 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. It's going to give us 8 plus 4 plus 0 plus 0 is equal to 12. So this is 12 in decimal, which is the same thing as C in hexadecimal. So you can now say that the hexadecimal conversion of this is 3FC. Does everyone understand? Yeah? Yeah, should work.
I can just cram it.
No, you're converting to binary now. So what you're going to first do is you're going to first group them into groups of 4 bits.
Yeah.
That should be working. So does anyone have any questions? Does anyone have any questions? So now we'll try converting from hexadecimal to binary. So we have this hexadecimal. I'm going to try to convert it to convert this to base 2. Means that there are two different ways you can go about this. What? Yeah. What? 6B5. Sorry, 5C. There are two different ways you can actually get this. You can actually do this by what? Yes, by separating it into different bits. Or you can first convert this to base 10, then to base 2. But doing the grouping method is actually faster. So I think you can try both, but we'll do this first. So now we have 4 groups of 4 bits each. So we're going to try to convert this into base 2, into 4 bits in base 2. So 6 base 2 will give us 3 remainder 0, 1 remainder 1, 0 remainder 1. So this is going to give us 0. Because it's 4 bits, we have to start with 0. And 1, 1, 0. That's for 6. And B as below in decimal. B in decimal is equal to 11. So we're going to convert 11 from decimal to binary. So that's going to be 11. So for B, we have 1, 0, 1, 1. 1, 0, 1, 1. So convert 5 also to base 2. Which is going to be 2 remainder 1, 1 remainder 0, 0 remainder 1. Because we are dealing with 4 bits, so we're going to start with 0, then 1, 0, 1. We'll convert C, which is 12 in base 10. Convert it to base 2. So this is equal to 6B5C in base 16. So all we just did was just to group the hexadecimal into 4 different sections of 4 bits each. So we converted each into base 2 to get our final result, which is this. Well, the other method, which is kind of what I just did, converting each of them to base 10, then to base 2. So that will be 6, and then 0, 1, 2, 3. So that's going to be 6 times 16. This is the base that we're working with. 16 times 3 plus B times 16 raised to power 2 plus 5 times 16 raised to power 1 plus C times 16 raised to power 0. So this is going to give us this is 24576 plus 2816 plus 80 plus 12. So this is going to give us 24. This is going to give us 27484 in base 10. And to convert it to base 2, we're going to keep on dividing 27484 by 2 until we get 0, which is quite long. Well, let's do it. 1, 2, 4, 0. 6, 8, 7, 1, 0. 2, 1, 7, 1, 7, 8, 5, 8, 1, 4, 2, 9, 2, 1, 4, 1, 0, 7, 5, 2, 6, what? Okay. Thanks. So this is going to give us 1, 1, 0, 1. One 1, 0, 1, 0, 1, 1, 0. This is actually similar to what we got with the other method. But everything is 0 in front, you're going to get the same thing. Because we group this. Just to confirm that we got the same thing. We're grouping them into four different sections of 4 bits. This is going to give us 6 in hexadecimal. This is going to give us B in hexadecimal. This is going to give us 5, and this is going to give us C. So that's just confirm. But the other method is actually shorter than this. Sorry, did everyone get this? Did everyone get this? Okay. So the last thing we're going to do for today is multiplication and division, or hexadecimal numbers by multiplication and division of hexadecimal numbers by 2. So I'm going to take, let's use this for example. This is in base 16. So what we're going to do to multiply, we're going to first convert it to base 2. Then to multiply, we're going to multiply or divide, we're going to move the bits forward by a single bit, or to the left by a single bit, or to the right. To the left for multiplication by 2, and to the right for division by 2. So first, let's convert this to base 16. This is going to give us, sorry, let's convert this to base 2. This is going to give us 0, 1, 1, 1, 1, 0, 2. So to multiply this, we're going to move each bit by one space to the left, which is going to give us 0, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0. So this is going to give us 5, yes? What? How did I get this? Okay. To multiply, I'm going to move. What? No, what? This is multiplication. I'm going to do division after this. Yes. Yeah. We are multiplying by 2. You are going to move each bit to the left. Yeah. From right to left. So I'm moving this. You are moving all the bits a step to the left, or from the far right to the left. So that means we are going to start from, yeah, just once. Yeah.
one. This one will be. This one will be. This one will be. Like that. So, you understand? This one is remove here.
Yeah.
This one here. This one here. Like that.
Yeah, this is multiplication.
Understand? So they keep moving like from the far right. This bit will move to the left. They will shift. Yeah, so at the end of the day, you find out that the one that's coming, whatever. So just
You guys understand now? What? We're going to start from 0.
if this one first one.
No, this one. It was 1.
Yeah.
No, it's just after. Yeah.
Two comments.
So,
Yeah. One here. And then it becomes 0. Then this one here.
no, it's not a division. No, division is not. That one starts from number. That's where you have a sign, most complement, choose complement. That's how you're going to do it. See it. If for because the code.
No. Let's do something else. Put one here and shoot it.
Okay.
Good. Do one. Do like one.
I just put one here.
Yeah, 110 and shoot it.
Okay.
And just analogy, not particularly CSC.
We are trying to get multiplication of the hexadecimal number, but we are going to convert it to binary first, then perform the shift function, then we convert it back to the 60 to get the multiplication. Yeah. Yeah. Just to clear the doubt, I'll put 1 here. So this is.
Guys, you want to try one here. So I want to see results when we shift it, when there's one here. This is not PFC in binary. This is just an example to show how it shifts when there is one and this is one.
So okay, now we're going to try converting BFC. So we're going to try multiplying BFC by 2. So this is binary conversion for BFC. 1011 1111 1100. So we're going to shift the bits to the left by 1. So now we're going to have 0 1 1 1 1 1 1 1 0 0 0. So now we're going to come. What? No, it's BFC. Now you know I'm changing this from 0 to 1. Yeah. Yeah. That's why we have 1 0 1 1 for the first conversion. So this now is. This is the binary multiplied by 2. So now we're going to convert it back to hexadecimal. So taking our groups of 4 bits, we convert this first. This is going to give us 7 F. So 7F8 is our what?
The same thing for CSC and PSC.
No. Yeah, the same thing. So now let's try dividing by 2. So do you guys understand? Should I explain it again? This is the binary conversion of this. So to multiply by 2, we're going to shift each bit by 1 to the left. I can change the position of each bit by just 1 step to the left. So that's why 0, 1, 1. So we're now going to convert this back to base 16. Yeah. Now I've got this. So now let's try dividing by 2. So when we are dividing by 2, we're going to shift the bits by 1 step to the right. So which means we're going to start with 0, 1, 0, 1, 1, 1, 1, 1, 1, 1. So we're going to convert what? When we're dividing by 2, we're going to change. Yeah, we're going to change to the right. So we're going to start with 0. Then this. So now we're going to convert this back to base 16. So this is going to give us yeah. So we're going to convert this back to base 16. So it's going to give us 5F 5FE 5FE base 16. So do you all understand how I got this? Okay. From when you are trying to divide, when you are dividing, you are going to move. You are going to change position of each bit by a step to the right. So we're going to start with 0. Then the first one is going to come here. Then next, like that until you get to the end. Just like we did for multiplication, I'll take it to the left. This time I'm taking it to the right. So after getting this, we're going to convert it back to base 16. We're going to group in. We're going to have 3 groups of 4 bits each. So we're going to get this and convert to 5FE. So that's how it came about. Does anyone have any questions? What? So I'd like us to try out this stuff now. Let's try convert. So you understand it now? Right, now we try multiplying and dividing these two. Yeah. What? 5 BC. That's it, like, to show that it's an hexadecimal. Yeah, yeah. Yeah. I'm going to correct it at the end of the semester. Yeah, try it, man.
I'm just done with modification for the class.
So I'm writing it for one now. That's one. So I want to make it not 001.
They don't first one. Yeah.
Yeah. This is 20 now. And you can have
Base.
20 decimal.
Yeah.
Then we want to convert to a decimal. Divide by 16.
Yeah.
16 here has 1 in our formula.
Yep.
16 has 0 in our number.
Yep.
So that's 14.
Yeah.
This 16. Now, say we want to convert back to decimal. Say we want to convert back to decimal.
Yeah, 1 times 16 is power 1 plus.
1, 4, and 1 times 16 is power 1 plus 4 times.
So 16 is power 0. Now 16 plus.
Plus 4.
That's right.
Yeah, exactly. This one is for multiplication.
Yeah.
Let me do subtraction.
The second one was fixed.
What do I get exactly? Division divided by 2.
Have you done division?
I'm not yet done division. I'm just
Okay. Sure. Yeah, after this. You're going to use multiplication and division of both of them. Yeah.
When you now divide this one, it's give back the same thing.
Hmm?
You bring back to the right, remember?
Yeah.
So it's give back the same answer. How much you give back the same answer again?
Just to be sure you know what you're doing.
Everybody, I get it.
Yeah. Let me check this.